Okay, good morning everyone. Thanks for attending InduSoft OPC webinar this morning here for the United States. I know it's afternoon, some other places off the road. I really appreciate you guys joining us today. We got great things here to present about the OPC technology and about how our products, InduSoft Web Studio and InduSoft CE View, how we handle the OPC technology. Let me go a little bit through our agenda here. My name is Andre Bastos. I'm let me just share my desktop real quick here. And let me just close my what's not supposed to be open. And my name is Andre Bastos, and I'll be presenting this webinar today. Here's our agenda. We're gonna have a presentation from Nathan Pocock. He's with OPC Foundation. Thank you, Nathan, for doing this. He's going to talk about the foundation itself, about the technology. We're going to understand a little bit more what are the advantages of using standard such as OPC, and then we're going to move into some a real world example from a hardware manufacturer, from let's say not only but let's say an automation provider. Stefan Hoppe from Beckhoff, Germany, was nice enough to get us a presentation that we're gonna show here, showing how they are applying the OPC technology on their products. I'm gonna show a brief history of OPC with InduSoft, and then show the different options that you have to use InduSoft as OPC. After that, I'm gonna show we're gonna have a hands-on configuration of the different OPC technologies. I'm gonna focus a little bit more on the UA part, the unified architecture part, and we go into the questions and answers part. Okay, so I'm gonna move now the presentation to our guest speaker, which is Nathan with OPC Foundation. I'm gonna stop sharing my desktop real quick here. And I'm gonna make Nathan the presenter.
Thank you, Andre. Okay, I hope that I've shared my screen. Do you see the welcome slide?
Yes, we do.
Excellent. Okay, so my name is Nathan Pocock, and I am with the OPC Foundation, and I am the Director of Certification and Compliance. And in this presentation, I will explain who the OPC Foundation is and what OPC technology is all about. So first of all, about the OPC Foundation, we are a non-profit organization founded in 1995. Been around for quite a while. We develop specifications for communicating data between disparate systems. The specifications are defined by the OPC Foundation members. It's a volunteer organization, and we have over 450 members all over the world. We do have extensive adoption in the manufacturing automation industry, and there really isn't another technology that competes with OPC. We're the only people that do what we do as far as exchanging data between different systems. And we like to think of ourselves as a future-thinking technology, and with our latest innovation, it really is a technology that will take us in new directions, new places in the future, and will really help us to grow. And when I say us, I mean all of us, the automation community. So that includes vendors and end users alike. So I wanted to show you some demographics as to where the membership is and some of the key markets that OPC is within. So as you can tell, we have quite a significant presence in Europe and in North America, but we also have quite a significant presence in Asia, and South America is also emerging quite nicely. So as part of what we do, we don't create products. We create the technology, and it's our vendors, our members, that actually create the product. So we are the evangelists of the technology. We do several different events throughout the year, various seminars, trade shows like the Hanover Mass that's occurring right now. We partner with numerous media outlets, and we do various training seminars as well for people that want to learn more in-depth details about OPC. And there's an important event occurring later this year that I will speak to later on at the end of this PowerPoint. So let's take a little look at life before OPC and understand why OPC came into place in the beginning. So I'm sure a few of you on this call will remember the days before OPC and the problem that everybody had where they were a prisoner of their own technology. On the bottom of the screen you can see various different controllers, and at the time each HMI or client application had to have an extensive library of plugins or drivers for different protocol implementations. So you might have Modbus, Profibus, Data Highway, various different protocols. And the difficulty was that all the other guys had to do the same thing. And sometimes HMI A might have a driver that HMI B does not. And you might have found yourself in a situation where you needed two different drivers, but no single package had those drivers. So maybe you had to buy two different packages or pay a lot of money for custom development. So that was life before OPC. So OPC actually emerged as a way to solve this problem by, first of all, moving to a client-server architecture, where the server is essentially a gateway, a protocol converter. So OPC is a very generic protocol. It's simply a case of read this, write that, give me a value for something else. Very generic. The OPC server's job is to take these very generic requests and to convert them into a device-specific protocol. So convert a simple read into a Modbus read, convert a simple write into a Profibus update. So it's quite a simple concept. So one of the features that OPC actually provided, well, it's, as I just alluded a moment ago, you could actually discover the availability of OPC servers on the network or the computer. We have this concept called tags, and tags are kind of like a Windows shortcut. Basically, you create a tag, give it a nice friendly name like temperature1. So that tag actually has a PLC memory address that it maps to. So in the client, it might say read temperature A, and when the OPC server receives that, it interprets that as I need to go read Modbus address 4001. You've got the ability to do on-demand reads, on-demand writes, and a powerful subscription model. But basically you say, hey OPC server, I want you to poll these tags for me. And when the values change, I want you to send me a notification. And that allows the client to not poll the server. So the client doesn't need to say, what's the value, what's the value, what's the value. It simply says, tell me when the value changes. And the nice thing about that is as more clients come online, so you can have more of your HMI clients come online, connected to an OPC server, the bandwidth between the OPC server and your devices does not necessarily increase. In fact, it may even remain unchanged. And the last thing I wanted to mention is this concept of qualities. So when you do a read, you get back a quality code, which will tell you if the value can be trusted or not. So for example, if I said read temperature A, but the device is not responding, I'll get back maybe a value that was the last value, but a quality code of bad, which tells me maybe I shouldn't use that value. Otherwise, the quality would be good, and that means that value is good. You can take that to the bank. So some of the benefits of adoption of OPC in this case were, The clients can now get out of the driver business. They could just have one driver, OPC. So the configuration of the client would be much easier too, because now you can just use point and click. You don't have to memorize PLC memory addresses. You just work with tags. You can read and write tags quite easily instead of having to memorize these addresses. And like I said a moment ago, the optimization on the wire was pretty significant. The thing is, over time, different problems needed a solution. They didn't have standardized ways of doing other things. And OPC could step in and solve those problems. But the difficulty was that OPC was already branded technology. So there was a rebranding that occurred. So this data, real-time data acquisition that we just talked about was rebranded as data access. So now other problems could be solved, and we could call those other things. So if we needed the ability to store historical data and retrieve historical data, that became the standard for historical data access. So now the standard ways of pushing data into a historian and getting data out. There was an alarms and conditions, which was a standard way of generating event notifications and a standard way of sending alarm notifications from a server to a client, a standard way of defining what an alarm condition was with subconditions and other logic that you could put in place. There were other standards as well for exchanging data between devices with data exchange. There was an ability needed to do data acquisition over the internet, and that's where XML DA came in. And all these other different technologies had solutions created for them, but there were some problems in this approach. So let's get back, first of all, to what the benefits were from the adoption. Like I mentioned a moment ago, vendors of the HMIs didn't need to create these expensive libraries anymore. Market of high-end device drivers, OPC servers, emerged. More specialized clients emerged. The nice thing about what happened is the cost of these products was reduced. So as end users, now you have the ability to pick and choose different products that you could bring in and make a system that actually fulfilled your needs without being a prisoner of your own technology. And the good thing is that when you bought an OPC product, it didn't matter if it was from vendor A, vendor B, vendor C, they just worked with each other. How do these products work with each other? Well, we have a compliance program at the OPC Foundation, and it's another open program where OPC Foundation member volunteers are participants within the group. We analyze the specifications, we create test cases and test tools, and those test tools are available to the members. These test tools will test servers and clients. We also do interoperability workshops, and the photograph on screen is a picture from a workshop where vendors take their products and they sit in the room and they literally connect their product to another vendor's product, do a whole battery of testing, and if they find problems, they're in the right place with other programmers to find and fix those problems. The most important thing that we have is the certification program. And the certification program is quite new. It's only a few years old. But basically, a product that is certified by an independent, sanctioned OPC test lab. Now, those labs are run according to a specification defined by the compliance working group, and those tests are much more extensive. So as you can see at the bottom right there, we're testing to make sure products comply with the specs, that they interoperate with other products, other vendors' products. We also do various error injection tests as well, where we might remove a network cable, kill a product that is connected to. So if a client's connected to a server, we'll just kill the server process and see how the client responds. Does the client crash? Hopefully not. Does it recover when the server comes back online? That's what we're looking for. And we also do usability and resource checking over 36 hours. Once a product is certified, we do give it a certificate, and you can see on the certificate at the bottom there is a serial number, so each certificate is serialized, and there's also a QR code, that little barcode looking thing at the bottom right, that when you scan that, it will go to a verification page at the OPC Foundation website. So you can basically get a value, a sanity check that the certificate is, in fact, genuine. So going back to the model that I said a moment ago that had a couple of flaws. So we're looking at OPC Classic here, where we've got a client and a server application. The colors, you can choose which is which. But the problem we had was each of these different specs were as separate can be. So a DA client could only talk to a DA server. You couldn't take a DA client and connect it to an HDA, a historical server, because the two technologies were different. Even though they were both OPC, they were different. So there was no unification of OPC within those classic specifications. And from a developer standpoint, there was a lot of additional work that went into creating each of these different interfaces. So it wasn't ideal. The problems were solved in one aspect, but a few additional problems were created in another. So how do you adapt to the new changes in direction, the way that technology changes all the time? And even though it changes slower in the automation industry, it does change. So how do you integrate those existing technologies into one cohesive technology? How do we get away from the Windows platform? Now, I'm a pro Microsoft guy. I love Microsoft. But the reality is Microsoft is losing its dominance, and different technologies are becoming more and more important and common. So how do you cope with that? How do you create a technology that allows you to grow over time? How do you allow your technology to work over the internet? That's becoming more and more critical nowadays. It used to be a luxury, now it's a requirement. How can you remain compatible with this multitude? There's actually thousands of OPC Classic products that are out there. How do you stay interoperable with those? You need to keep the performance, you need more capabilities, and most end users are just saying, I don't want decom headaches anymore. Well, the way that you get away from all of these problems and move to a different direction is you start from the very beginning. So OPC, about 10 years ago, started at the whiteboard and completely re-architected a new technology. So this new technology incorporates every single existing specification we have into one new technology. This technology gets away from the Microsoft model and now uses other platforms that are standard all around the world. And when you do that, you look at what you've created, and you've created something called unified architecture. So what is unified architecture? Well, it's a new technology. It's been out now for about 4 or 5 years. It incorporates everything that OPC Classic did. So now as a vendor, if you incorporate OPCUA, you might do the equivalent of what DA did today. But tomorrow you might say, I need historical. And from a developer standpoint, all you have to do is add those few little differences that give you historical capabilities. You don't have this massive library of interfaces to create, maybe just 4. We have various different proxies and gateways that will convert between OPC UA protocol and OPC Classic protocol. So now you can take a UA client, connect it to a Classic server. Take a Classic client, connect it to a UA server. You've got this crisscross of technology that you can now use with new and classic technologies. We've also accomplished the goals that we set out for security, and I'm about to get to that in a moment, for performance, for platform independence. So everything you know about OPC Classic, the way that it works, all the rules, all the names, all the terminology, everything's now carried over into OPC UA. So here's a little eye chart that shows you a very high-level architectural look at OPC UA. So at the bottom, we've got the red box that shows different protocols. OPC UA gives us several different protocols. We've got web-based protocols, and we've got binary-based protocols. There's pros and cons to both. Depending on what you need, you have options. The blue box is our data model, where all of our different object types are defined. The green box are where all of our functions are defined, our reads, our writes, our subscriptions, our browsing capabilities. Everything goes in that green box. Now the orange boxes that say DA, AC, HA, those are what we call profiles. Now basically, each of those profiles is basically our OPC Classic specification equivalent. The DA in UA is the same as DA in Classic. And what it does is it grabs a set of data types from the blue box, grabs a set of methods from the green box, and says, these methods are what we need to create a DA server or a DA client. In the AC, it will grab the different data types it needs from the blue box and the different methods it needs from the green box, and now that's the AC equivalent, or the alarms and events condition equivalent from Classic. From the L-shaped boxes, you can see that the model is extensible, so you can just layer your different information models and profiles on top. This is what's going to allow new specifications to be developed over time without breaking existing specifications or different applications that already exist. With platform independence comes a lot of freedom. So now OPC can exist in places outside of Windows. We used to be confined to Windows. Now we already have implementations of OPCUA on a chip, on a Windows CE, on tablets, on servers, on iPhones and iPads. We also have OPCUA products naturally on Windows, but also on Linux, on Android. You name it, there's OPC implementations already there or in development. So we talked about security, and in this day and age, security is quite high on everybody's list. Well, this is quite a big feature in OPCUA. Each application now has its own identification. We use X509 certificates. So an HMI, a client, will have a certificate that uniquely identifies it. A server application will also have a certificate that uniquely identifies it. All applications do. When an application connects to another application, it has to provide a certificate so that the other app can check its trust list to see if it trusts that application. If it doesn't know this application, then it can reject the connection. If the application is in the trust list, then the connection will go ahead. The connection can be secured, meaning that the packets are encrypted and digitally signed, or they can be raw, unencrypted data. And you might use the raw, unencrypted if you're on a closed circuit network where you want high performance. But most of the time, with the horsepower available in the network and the computers nowadays, going with encryption is probably the best way. So we use standard algorithms, we use standard technology. Everything that's already in wide adoption all over the world is what's used in UA. Each message, each UA packet that is sent is sequenced. So there's a sequence number, and that allows us to be somewhat immune from people like hackers that might record messages and then play them back later. Imagine if somebody did that to your Modbus devices. They sit there, they capture various packets, go into your Modbus device, wait a few seconds, and then just replay them back out again. You could be doing various writes to that device, and later on, those writes would go out again without you even knowing about it. But these sequences can allow clients and servers to detect if messages have been lost. We have the ability to re-request messages that were probably lost on the network, or maybe were intercepted somewhere else. Basically, different applications can detect these different problems. Once the connection is made between applications, then the user can be authenticated too. So in every way you look at it, when you look at security, all of these things are options. You can turn them on, you can turn them off. The choice is yours. But the features are built into the technology. So they're there. Even if you don't want to use them, they are there waiting to be used. So users can be authenticated by logging their password. Maybe the users have a certificate the same way the applications did. There's all these different ways a user can be identified. Once a user is identified, you can then get very technical with access rights. So you might say user A has complete access to everything, whereas user B, they can only see a subset of the tags that are available. Perhaps within that subset, they can read to some, but not others. Perhaps they can write to some and read, but not others. So you get all these different choices. Now, the big thing that's quite new here is the ability to do auditing. So you can log all of the activities that are going on. So who did what? When did they do it? You can use this information to figure out what happened at a certain time. If some big alarm goes off, you can look at these audit logs and see what activities were going on leading up to the alarm. So just a little summary of what OPCUA gives us. So we've got the platform independence, we've got reliability and robustness built into the architecture itself. We've got the sequencing, we've got the encryption, we've got all these other capabilities that I haven't mentioned just for brevity that are built into the technology itself. We have this great information model with these profiles that will allow us to add more specifications over time. We're not just dealing with values anymore. We're now dealing with information. So in data access, it was getting a value. In historical data access, it was getting me lots of values in a record set. The alarms and conditions or alarms and events, this was a bit more information driven. Well, in OPCUA, we have complex objects now. We have the ability to send structured data over the wire in a way that other applications can understand it. We have the performance, we have the security, we have the wrappers and proxies for compatibility with Classic. We've got rid of the dreaded decom headaches. The big thing that we've got though now is a certification program. Did I mention that certification is such a big topic for us that it's free for the membership? That's right. OPC Foundation members can certify their products at an independent test lab where I'm sat right now here in Scottsdale, Arizona. We test products for our OPC Foundation members. We do all of those tests that I told you about. That's the membership benefit. That's a benefit that we give to our OPCUA adopters because we want the technology to be the best it can be, and we want the end user experience to be the best it can be also. We do this because we're helping our vendors to achieve the best success in their products, the best their product can be. So I just want to wrap up now with a little plug for an event that we have scheduled for October. This is a 3-day technology summit. If you are considering making an investment in OPC technology, perhaps you are looking at making a large acquisition of InduSoft or other servers, then come along to this event. We've got a great lineup of speakers, a great agenda that we've put together. You will walk away with a lot of inspired ideas, I promise. So we have a website where you can go check this out. More information will be coming in the next few weeks. And that's basically where I wanted to wrap up. So I'll remain online for any questions at the end of the webinar. Andre.
All right, Nathan. Thank you very much. Thank you very much. It was very, very instructive. I really appreciate this presentation, Nathan. Thank you very much. So, I'm just retrieving my role as presenter now. What I want to do now is I want to show you guys a presentation from a real world vendor, which is Beckhoff Automation in Europe. And I want to show how they are, let me share my desktop here, how they are applying the OPC technology and mainly the OPCUA technology into their own products. Okay, so I'm gonna play this video, this presentation that Mr. Stefan Hoppe was very kind to provide us with. I hope you guys enjoy it.
Hello, my name is Stefan Hoppe. I'm a product manager at Beckhoff Automation. This talk is about OPC Unified Architecture integrated into embedded PLC controllers. So I'm working for Beckhoff, which is a family-owned company inside Germany. We do all about puzzle pieces round about industrial automation solutions. So from motherboards, industrial PCs, IOs, but also a real-time extension for the Windows operating system. So we also were very committed to OPC. So we are an early member in '98 and had a first product in '99. But today in 2012, We have OPC Unified Architecture, Data Access, Historical Access, and Alarm and Condition integrated into our embedded devices. We are also very actively in European working groups. One of the working groups is a cooperation between Unified Architecture and PLC Open, and this is what Beckhoff drives as a chair. The idea is to have a common mapping of the PLC Open object model into the OPCUA namespace. The next level, what we are working right now on, is to create PLC Open function blocks, which enables a PLC programmer to communicate out of the PLC controller with Unified Architecture client functionalities to other solutions, to other servers in the network. The benefit of this is for OPCUA clients like SCADA, MES and ERP clients, because when all automation vendors of PLCs provide their information model from PLC Open in the same way via OPC Unified Architecture to the outside world, so the clients will have the semantic identical access to the servers. So there's rapidly engineering and they can reuse all their HMI faceplates in the future. Definitely the PLC controllers become more transparently. Beckhoff is also very involved in the next step. So if the PLC Open activities have been done right now, we will create and help creating in the next working group for MES connectivity. This is in cooperation with other big, huge organizations, because we do not want to create a new MES standard. Instead, we are cooperating with MES experts to use their information knowledge and their knowledge about specific MES profiles, but make use of the secured OPC Unified Architecture transport channel. Beckhoff integrated Unified Architecture into two major products. First of all, we have a royalty-free OPCUA server delivered with each Beckhoff industrial PC. Because the industrial PC is the heart of a machine, of course we need always a good status of the machine about the CPU temperature, if it has a fan, the speed of a fan, how much memory is consumed and so on. So we integrated a royalty-free UA server into all of our machines. We designed a common abstraction layer for diagnostic and configuration, which is identical on all operating systems, and we have different connectivity channels into that abstraction layer. So there's a web page, but we also needed a remote secured connection to industrial PCs, and so this is exactly what you see here, the Unified Architecture access to allow from outside or local a completely fast, reliable, secured connectivity into the abstraction layer. Of course, you can also access it out of the PLC, and at the end we can collect something like the CPU frequency, the current temperature, the CPU usage, or the fan speed, but also all about operating systems, the versions, and so on. This is royalty free. But of course we also provide PLC logic and motion logic, and here we have a second OPCUA server, and here we provide data access, historical access, and alarm and condition already integrated into the smallest embedded controller. I think today we are one of the first, or even the first, international company having and providing an OPCUA client functionality as function blocks out of this PLC controller. So this PLC controller can initiate a connectivity to another UA server somewhere in the world. The reason for that is that we definitely think that also SCADA systems or ERP systems in future are not only acting as a UA client like in the traditional history, but instead they are also in parallel provide a server interface. So which means the controller is not only acting as a server but also acting to initiate a connectivity, acting as a client. So how to configure UA functionalities in our PLC? First of all, our UA server requires for the basic steps no configuration. This was very important at the design. So for example here, if you create a little bit PLC code, you just provide a command behind the PLC variable declaration. For example, in this case, we declare as a command that this is a variable which is acting also as a historical access symbol. It's stored in the memory. We have a sample rate of 250 milliseconds, and we store 20,000 record sets of this specific variable, including the value but also the timestamp. So doing this, the PLC will store all the data, and you can check is it you can configure is it stored in the RAM, then it would be not persistent, or should it be really stored in a local database. So you can even do a power cycle, and after the power cycle all variables are still available, which means UA historical access client can also read the data and the record sets from the server of the history. So you can provide a specific time frame and request the data of a specific time range from the server. We are definitely one of the first companies having certified our OPC UA product in the OPC Lab in Europe. So the TwinKit OPC UA server is certified by a third-party company. Our products are already out in the industry. So for example, Areva is a company for offshore wind turbines in the North Sea, and there in the turbine there's running a embedded controller with PLC and integrated UA server, and the UA server provides connectivity to the IT landscape. Company Miele in Germany connected the Siemens WinCC HMI to the Beckhoff TwinKit. So here's also one of some samples. This is how we can really do a very small embedded board. It's not the cost of $1, it just should show the size of the small motherboard, and this small motherboard has 20 general purpose IOs, but also act as a OPC UA server in the network. Definitely we showcased with company SAP how to connect from the smallest embedded controller up into the enterprise world. So there's a demo where you can connect from SAP directly via OPC unified architecture into an embedded controller. In case of any questions, let me know. My email address is here, s.hoppe@beckhoff.com. This was a talk about OPC unified architecture integrated into PLC controllers. Thanks for attention.
Alright guys, so this was Stefan Hoppe's presentation with Beckhoff. Very interesting presentation where you can see the real world applying the OPC technology on the manufacturer, like PLC manufacturers. In the case of Beckhoff, they come already with an OPC UA server on the PLC itself. And I'm going to talk a little bit about how our company InduSoft has been applying the OPC technology over the years. Okay, so that's the third bullet here on our presentation. So we have seen already 2 presentations showing where how you apply the OPC technology and the different specifications. We as a company, InduSoft, we've been having the OPC DA, now rebranded as OPC Classic, for a while right now. We added OPC XML. We are one of the first ones to have OPC UA client and OPC.NET standards already on the product. So historically speaking, when we were back in 1998, 1999, we had already OPC DA client. You know, whatever specification was there was specification 1, and then went into specification version 2. I remember back in 1999 we were already presenting our OPC client also for Windows CE on ISA trade shows, you know, Chicago Manufacturing National Manufacturing Week. So we had already the DA client for both PC and Windows CE. For people that are familiar with InduSoft for a while now, you know that we've been one of the first ones to introduce a Windows CE product to the market as a complete solution. And back then we even had an OPC DA client on Windows CE. On our version 4.1, we enable our DA server. So the same way as Stefan Hoppe mentioned on his presentation that the HMI and the SCADA, they are traditionally OPC clients, but they may become OPC servers as well. Yes, we agree with him on that, and that's why we developed a DA server for our product as well. On the version 5.1, we made the DA server available for Windows CE as well, and we made our historical data access available for PC. So all the trend history information that is stored using InduSoft Web Studio, we make available for HDA clients, so historical data access clients as well. On version 7.0, we introduced our UA client, our .NET Trio client, and XML DA client, first for applications running on Windows PC. So that means, you know, Windows XP, Windows 7, 2008 Server, Vista, and all this type of things. And we were one of the first adapters on .NET and UA client out there. And the upcoming version 7.1, you know, is gonna be out in just a few weeks. We're gonna have UA client for Windows CE as well. And during this presentation, I'm gonna give you guys a preview of that UA client on a Windows CE device that we have here. So what I have in mind now, I'm gonna show you guys a little bit about how you configure the different OPC flavors using InduSoft Web Studio. So I'm gonna switch some computers that I have here. I have some computers with a couple OPC servers. I have one with UA servers, and my the computer here that I'm presenting, I'm gonna also remotely connect to a few servers, and after that we move into some questions. So the first one that I'm gonna show is the OPC DA option that we've been having for a while. I will not spend much time on this. I really want to focus on what we currently have and what we believe is going to be the future, which is the OPC UA part. Okay, so on the OPC DA, the main points on the DA on InduSoft Web Studio is very simple to configure. So you have the browsing capabilities, and we subscribe to tags, and we'll write whenever a tag changes on InduSoft Web Studio. We'll write that to the OPC server, or whenever the tag changes on the server, we read that value from the server into InduSoft Web Studio. Okay, we support remote OPC connection, and we have an import wizard for an OPC server as well. So I'm gonna switch here to show the InduSoft environment. Okay, that's our development environment here. I have a couple of demo applications that I have prepared here. So if using InduSoft Web Studio, I create a brand new project. I'm just creating a project right now. All right, so when your target is for a Windows CE system, you have the traditional OPC DA 2.5, and you have the OPC UA connections now on our newer version, the upcoming version 7.1. Okay, so if I change the target for one of our PC target systems, then I have all the different flavors of OPC. So it can be .NET, can be DA, can be the XML DA. Okay, so I'm gonna show one of my remote computers here that I'm connecting I was connecting through VNC. Let me see if I can find that computer real quick here. So here's the PC. So on this computer, I have a couple of OPC servers installed. You know, I installed some of their demo versions, so I could at least show some of those OPCs here. So if I go here and insert one of these OPC servers, the way I'm gonna configure that, I'm gonna basically select one of the available OPC servers that I have there. So we have the OPC server from Metricon. We have a software toolbox here. We have a couple of simulation OPCs, and for instance, if I select this one here, if I'm going locally, I don't need to type anything here. Otherwise, I would put here the IP address of that server or something like this. Very simple configurations. We say how often I want the server to read the data and sending the data to the PLC. This is very important to optimize the communication with your remote device. Let's say that you're gonna have 1,000 variables and 500 of them are temperature. Well, the temperature is not going to change much within a few milliseconds, you know. So if you tell this guy, oh, I want to read, let's say every 1,000 milliseconds, that's going to be fine, you know. And using InduSoft Web Studio, you can create different worksheets. So you could have one worksheet for the temperatures with 1,000 milliseconds. You could have a separated worksheet that would be read, let's say pressure, that you want to have a better update rate that's going to be reading every 200 milliseconds or so. And then you pick which server you want to connect to. And what you do on InduSoft Web Studio, you're going to associate the existing tags, or you can create new tags. So I go here on my project, I select one of my tags here. I'm going to select my alarm tag too, and I'm going to associate that to an OPC item. So I go here, right click, select the browser. That's going to start the OPC server, if the OPC server is available, and then I can go and pick which item I want to connect to on the server. So this information here came from the server, okay? So I don't need to remember the tag names. I don't need to so for instance, I just pick here the item, I click OK, and there you go. At this point, this tag here, alarm analog, is associated with the square waves real 4 tag from my OPC server. Okay, and then to optimize the communication, I can pick if I want to communicate with the tag always. So that means that whenever the tag changes on the server, I'm gonna read that, or only when I have the tag on the screen. On the screen is particularly useful when you're reading parameters. We're gonna write parameters. Let's say that you have a PID loop, and you're gonna change the proportional, the derivative parameters. You don't need to be reading these guys all the time, you know. So only when you open the PID screen that you're gonna enter those values, then you're gonna create the link to those tags. Okay, so you can do that for each one of the tags, and that optimizes the server performance and the overall system performance. And you have the option called auto, which we introduced on the version 7.1. The auto we create by default as the screen, but if I use that tag in a script, in a scheduler or anything like that, we change that to always, you know. So we know that I don't need that guy only on the screen anymore. Okay, so that's very simple. You have here a field to disable the communication, so this will disable the entire worksheet. So let's say you're gonna do some maintenance or something like that. You have a tag here, so you go on the screen, you're gonna disable the communication, so we will not be getting values from the server that are not interesting for us, you know, while I'm doing some maintenance on the machine. You know, temperature may go up and down, generate tons of alarms. You may disable that. And you can have here a tag that will receive the status of the link with the server. So the status, basically every 5 seconds, we call the get status from the OPC server. If the server is fine, we receive the value 1 on this tag here. Otherwise, we receive an error from the server. And I'm gonna show here on our debugging tool when we have a tag. So here I'll have the value, but we have also this field here called quality, which I can access in my application anywhere if I just type the dash greater than quality. Okay, 192, which is C0 in hexadecimal, means good quality. So if I get the communication from the server and the quality is good, I'm gonna receive that value here. If by any chance the server lost the communication with the PLC, or the PLC is in error, this server is gonna tell me that the quality is not good. So I'm gonna receive here on this tag a value, but I will also receive the quality telling me that that value is not good. You know, that's probably not what's happening on my process. Okay, this solution, this OPC DA205 is being our product, you know, forever. Since 1998, 99, that's when we started using that. This is available for Windows CE as well. And you know, as the technology evolved, we made our OPC Server available as well. So in any project that you're running, you have this option here to enable our SCADA OPC Server. If you make this guy enabled, we're gonna start serving all of our tags, system tags, application tags, so you can have any OPC client connecting to our server here. Okay, so that's the traditional OPC client that we have on the product. I'm gonna save this worksheet here. Okay, and we could have multiple worksheets, as you know, as I mentioned before. All right, so that's a very simple way to configure that. But that brought also some challenges. Okay, what if I want to force a read? What if I want to write an entire group of variables? How do I know that I just finished reading something? Some of our users, they use our communication drivers as well. So they liked the idea that you could individually control some worksheets, not saying, okay, read all the time. No, read only when I have a trigger. You know, and the OPC specification provides that. So we came now with a new concept on the new 3 flavors that we have on OPC. Let me show that here on this slide. So our XML DA configuration is pretty similar to what we have on UA and .NET. We still have the browsing capabilities, but not only we can read and write only when a tag changes, either on the server or on the client. You can also use the triggers to trigger a transaction, and you have the feedback with integer tags that are counting how many reads I had, you know, and the status not only on an integer number but also in a message. Okay, so I can have a string showing me which error I'm receiving from the server. Okay, and the concept of connections. The connection is gonna be at one part of my system, and then on the worksheet I'm gonna associate that with the connection. And that same concept applies for our OPC UA. So I'm gonna quickly here show, if I'm using one of our new OPC XML DA features, I can insert here a new connection. On the connection, I give a name. So here's our window showing the server connection, and this new interface supports DA 2.x or DA 3.0, but also XML. As Nathan mentioned before, you can go over the internet when you have XML. And the interface is pretty much the same. So if I'm going locally with DA, I'm gonna go here and pick one of the servers that I have available on my computer. So I pick, for instance, the simulation here. If I'm using XML, I could configure that as with username and passwords. Okay, and I'm gonna give this a connection name. And there you go, I just created my connection. So once I have the connection, I can also now insert worksheets and associate those worksheets with the connections that I have created. So right now I created the DA connection. It's pretty similar to what we were doing before, how you're going to associate an InduSoft tag to an item. So I pick the tag name here. So I'm going to pick, for example, my analog alarm, and I'm going to associate that with an item from my server. Okay, so I right click, I select the browse, and I'm going to be browsing that server that I configure on my DA connection. Okay, if I properly configure that. Anyway, what we have here also is on advanced is this new window here that allows you to configure all these things for a traditional DA or XML communication. We can enable the subscription. I can have a tag here, so that will be equivalent to enable or disable, you know, subscribe or not to an item. We have the synchronous and asynchronous triggers for both reading and writing. We have the count fields. This tag is going to be incremented whenever I finish reading something from the PLC or whenever I write something from the PLC. We have status as an integer tag as well as string tag. So if anything goes wrong on the communication, this tag is going to be updated. Okay, and several of these guys, they support changing over the runtime. So for instance, we have the aging feature, and I can put a tag here and change this value. Okay, but it will not take place right away. I can have a reload trigger that will allow me to, whenever that value changes, when the trigger changes, then I take the new maximum aging. And this trigger is also used to get a new publish rate. So our publish rate here, I could either put a fixed value or I can put here a tag. So whenever this tag here called rate changes the value, I'm going to change my publish rate only if the tag that I put here as a trigger changes the value. All right? So this same concept, we apply it also for our UA connection. So when I go here on UA, I have already created a connection here that I called A. And the interface a little bit different to make more sense for UA connections. So I click here, I can browse the OPC servers that I have available on this computer. So on this computer, for instance, I have, you know, a Beckhoff TwinCat OPC UA server. If I enter here other computer name, let me see. I guess this one here. I serve. So on this other PC here that I have with my IP 162, I have a UA sample server from OPC Foundation. Okay, so I can just pick whatever server I want. You know, when I click OK, I'm gonna assign that, and I can also configure all the security that Nathan just mentioned. So here I can choose if I'm gonna assign. I don't have a client certificate right now, so we can create a certificate. So I click yes here, and I can create a self-signed certificate. Okay, generate the certificate. So that's gonna go on the project under the config folder, our certificate. So I can send a certificate over to the server as well. Okay, and I can create a trust list of certificate issuers and my own trust list. Okay, so I have the button here to trust a server certificate. So when I click here, I can pick after, of course, selecting a server certificate, and I can create my own self-signed certificate. That's what we just did. Okay, so once I configure all that and I have the server with all certificates, I can click on the test connection. I just test my connection to the server. If anything goes wrong, like if I have the wrong name or password, when you're configuring the server, you can have users and password. So that's another added security. So you have all the certificates, you have the concept of users and password to the server. So once we have all configured, we can go and test that communication with the server. Okay, so I want to show here I'm gonna show in different computers. We had this presentation from Beckhoff, and that's one of the servers that I want to show here today. So on this computer here that I'm running remotely, we have configured the demo project that comes with TwinCat to serve OPC as well. So basically, what you have to do is, you configure the symbols to download the symbols to the PLC, and on the comments, I make it the OPC available for clients. I download that to the target. So I have already downloaded that to the target. So I'm gonna log on, and here I have the values that are changing. You can see this tag called steps, changing values. You have the counter here showing 961. Okay, and on InduSoft Web Studio, let me switch here to InduSoft Web Studio. I'm gonna open one of our demos here. So I'm gonna open, for instance, our TwinCat demo here. And on this demo project, I'm going to configure my connection to connect to that specific PC. That PC is this one with this name here. Okay, so if I'm gonna create a new, if I were just creating the connection, I would, I don't know, enter a name here and point to which PC I want to connect to. So it can be the computer name, or could be the IP address. So it shows here my Beckhoff server on that computer. Okay, we did not need to have DCOM or for the old timers. If you guys remember the OPC enum program, everything. No, what we have to do is to properly configure the server to have the discovery service available, so we can remotely connect to that server. So I have other PCs here, like I was showing the 162. So here it lists the servers that I have available there. Okay, so that's simple enough, but when you're configuring a server, you can provide all the security that you want. So on Beckhoff case, you can say if you're gonna accept only subscriptions with sign-in encryption, what type of encryption, if you're gonna have users and passwords configured for that, or if you're gonna allow any type of connection. So let's say that you are not intranet, you are not that concerned about users and passwords from your own client to your own servers. You can have a transparent connection like this. So on this connection that I have created here with TwinCat, I can test the connection. The connection was established successfully. So I created one worksheet, very simple worksheet. When I configure a publish rate of 50 milliseconds, I configure some of the parameters like the read trigger, a read counter, aging, to enable or disable the subscription, and to associate our tags to the server items. All I had to do was right click and browse, and the items came from the server. Okay, so here are the items that I made available on that server. So for my switch, I select here the switch and click OK, and associated this guy to my work item, to my tag name here. Okay, this project specifically, as I'm gonna show, this project, the target is actually I make that target for Windows CE, and I'm using our beta version of our version 7.1, so we can have this available for Windows CE as well. Okay, and so if I run this guy locally on my PC, I'm gonna be running on emulation mode, but it's gonna use our UA module locally here. So I can compare, for instance, my counter here on this demo. These values are coming from the OPC server. So I'm gonna show the other machine. that's running TwinCat. So you can see here the counter with 993. I can change this guy to, for instance, I'm gonna write a different value. So I just wrote 555 on the server, and I already got that value here on InduSoft. So I'm gonna change the speed. I'm gonna write to the server, I want that to be faster. So you can see here that I made the speed really fast. It changed the speed value on my server here. I'm gonna disable the subscription. So I just stopped reading. You see that the server already have the counter as 558, but I have still the value 557. Okay, and I stop it. So I'm gonna go ahead and re-enable. So I'm reading again. So if I do here on my test, I can disable reading. So I'm not reading anymore. The server already has the value of the counter 561. The step says 25, or now I have 562, and I can have the trigger. So I triggered. I read the value only when I use my read trigger here. And you can see the reading commands changing the values here. That's the counter. This 1350 is the counter that we have configured on the worksheet. So read trigger, it jumped from 50 to 61 because that's how many items I have on that worksheet. That's the total that I have read from there. Okay? And that's the same thing if I wanna write. So I'm gonna here on the counter, and I'm gonna use InduSoft to write a value, let's say 255 to the server. My writing counter counted here to 9, and the server already up at that value to 256. So this I'm running on my PC. Okay, what I'm very proud to show you guys now is that this same project I am able to connect to a remote Windows CE device, download that project to the Windows CE device. We are connecting to a device that runs Windows CE version 7, and is a x86 processor, is an add-on processor. And I'm gonna show remotely here that Windows CE device running that same project we were showing. I'm using here VNC. It's as you guys can see, if you're familiar with Windows CE, that's the Windows CE interface. But we are running here Windows CE 7 on an x86 processor. This is our runtime for Windows CE, where we are showing the values coming from the server. So I'm gonna compare my Windows CE runtime from here with my server machine. So you can see the values not completely updated. Let me go here on the driver. Oh man, so you see we lost the communication, and I have the status showing me here 221,000, and if I try to read, it shows me the error. So if you guys don't mind, I'm gonna just try to restart, but yes, we lost the communication to the server, so we got the errors here. Alright, I believe if I just restart, I should be fine. Let me hide the keyboard here. So here's our runtime map. It's loading the screen. So we have the values here, 272, now 273. I can write the values to the speed. So if I go here on the Windows CE screen and change the value, so I'm writing a new speed to the server. Okay, so I'm gonna go here, change and write. So I just wrote a new value to the server, the value 13 to the server, and the same thing that I was doing on my PC, I can do on the Windows CE as well. So I can write new values to the counter. So I enable here the keypad. So I'm gonna write, let's say 40 to my counter tag. So I wrote that value to the Windows CE runtime that I'm running here. Okay, and that on Windows CE using the UA technology that we were just talking about now. If I want to debug the communication that's going on in the Windows CE from my development environments, I'm gonna click here if you see on the mouse, on the back I still have InduSoft development environment, so I can click on login. On my login here, enter the IP address of my Windows CE device. And I'm gonna be able to start logging the communications, the OPC communications that are happening there. As soon as we connect to it. Okay, still happening here. And I may need to take a look on what's going on with my login later. You know, still beta, and this may be one of the issues that I may still have to work on. Anyway, okay, didn't connect. Oh, I mistyped the name. And yeah, it basically timed out. And I guess that's the IP address of the device. So here it is. So I can it asked me to enter a user and password because I have. So I'm gonna log here. I can log my OPC messages if I have an error or anything like that. Here I'm gonna show, let's say if the server stops or anything, this is gonna show me the errors that I've been having on my UA communications on a remote device, even on a Windows CE device. Okay, so this is, you know, a Windows CE runtime. This is a PC runtime. They both communicating over OPC UA to a real manufacturer, which is Beckhoff, running TwinCat on this remote device here. I'm showing on the PC. I have no way of showing if this was on another device like this. And that's pretty much all you have to do to have the UA communications. It's as simple as that and as safe as that. Again, you create the connection. When you're creating the connection, you can configure all the security provided by the UA spec. Once you have configured the security and everything, you can test the connection. If you know the IP address or the computer name where your UA server is, it's very simple. Just to browse the endpoint. So here shows my local servers. I have here the sample server on this computer, but if I type other computer name here, it's gonna find the other computer server. Once I connect, I created the connection. I go here on my worksheet, I select which connection I'm going to connect to. I can configure the tags for the status of the overall communication or the specific status for reads, for writes, the integer number, the messages for that, the triggers, and for writing and for reading. If it's gonna be always or only on screen, that I'm gonna access that tag, okay? And this is also good for, you know, for arrays, and we can have values coming from the PLC that we can rescale before we put those values into the InduSoft tags. Okay, so if you guys allow me here, I'm gonna move just to show a little bit about our OPC D8 server that you have on InduSoft Web Studio. And we already have a prototype of our UA server for InduSoft Web Studio as well. It won't be available on the release of version 7.1. We are still, you know, developing more of that, but you know, pretty soon you're gonna have a UA server for InduSoft Web Studio products as well. Okay, so our DA server that we currently have uses the spec 205. We always test that in all the interop event since, you know, 03, so it's been 9 years now that we've been testing it on, you know, the interop here in North America, and recently we started testing those on the European interop as well. Has that advantage of, you know, it can run as a service. So if you have your SCADA running as a service, acquiring data from the PLC, instead of, you know, running as an application, don't need to log on to that computer, you can have your MES system as a OPC client collecting this data that we are getting from the PLC into any OPC client, It serves all the system tags, application tags, and even our device tags. That's what we have, the tag integration. And that server is available for both PC and Windows CE. And that's what we're gonna do also with our product with our UA server as well. So currently we have the UA client for PC and CE coming up on the next weeks. We have the .NET and XML client for PC, and we have also the .NET, the OPC.NET. You know, there's a different technology that's coming out there as well. So I'm gonna move now to the Q&A session. You guys can submit your questions through the chat, and I'm gonna start answering as they come here. Okay. Okay. I've got a good question here from one of our customers, and I'm gonna even take the chance here to show you guys that when you're browsing items from the server, do we have a way of browsing multiple items? The answer is right now, no. When you're browsing items, doesn't matter which technology you're using, you associate one tag to one item. We currently don't have a way, let's say, to even on on the DA. So the window is pretty much similar to the UA, that you could select, let's say, multiple items at the same time. So the way we associate is one item at a time to one of our tags. Okay, so what we currently have is, and I'm gonna open a different project here real quick, probably in one of my other computers. Let me go to one of my other computers here. So I'm gonna just quickly here create a new project. And one way that we currently provide you to import multiple items into Web Studio is through our import wizard. So I can go here on my import wizard, and we have the OPC server database option. So using that import wizard, you can select one of the OPC servers you have available. Let's say that I pick sort the toolbox. I can select a specific branch. So I'm gonna import everything that is on my device 1, or my device 2. Let's say everything on my channel 1. I can use the item path for the tag name, use a prefix or something like that. I go next. So here it's showing the items that I have for that server. Okay. Or if I go back and I have no branches, so I'm gonna go to the very root. Let's say we're gonna import everything that is in there. Channel 0. So I go here, and okay, maybe that's all what I have on this server. Let me see if that's the case. Oh yeah, no, I got more. So here we have all the items that are on that server. I can choose which ones I'm going to, so I can filter. For instance, I want to import only the booleans, or I don't want to import the integers or something like that. So you can create a filter here. I'm going to import only the tags that start with B, for instance. So we filter that. And then I can choose the option to import only the filtered tags. I'm going to be importing only 19 tags. Okay, so I do this, I finish. We imported several tags into this project. Okay, so we go here and we have imported these tags into our worksheets that we created automatically. Okay, will we have something like this on UA? We're gonna have something even better than that. That is on the works. We're gonna have a full integration with UA to import more tags. We support arrays, you know, on UA. So I hope I answer this question for this customer. I don't see any other question here coming up. So we are running over 1 hour and a half right now. What I want to do now is I want to show you guys the ways that you have to contact InduSoft. We have our offices in the United States, here in Austin, Texas. We have an office in São Paulo, Brazil. We have in Germany, in Waldorf at SAP. You can see the pictures of our offices there. The phone numbers, you know, to calling any of these offices for, you know, tech support, for sales, for any questions that you may have, and our email addresses. And right now, I just want to thank again Nathan with OPC Foundation for his presentation. I want to thank Stefan Hoppe with Beckhoff for his presentation as well, and I want to thank each one of you that attended this presentation. It was really important that we had the attendance that we had. Thank you guys. You're gonna be again at 4 p.m. Central Standard Time, United States, this afternoon, presenting this again. If you guys want to see that again, you're more than welcome to join us again. Okay, thank you very much, guys. I really appreciate having you guys around. Have a great day, everyone.